Good evening, millennials. Today we'll be looking at the 113th sum of the LeetCode. I will be reading the question, discussing the solution, and I will be coding on the fly like I would have done in an interview. If you have any doubts, please leave it in the comments, or any scope for feedback, please do leave it in the comments and I'll look into it. So let's look at this question, and this is a very common question asked in many famous interviews like Amazon and Google. So let's read the question and let's think step by step. The sum is path sum 2. So given the root of a binary tree and an integer target sum, okay, return all the root to leaf paths. So we have to return all the root to leaf paths where the sum of the node values in the path equals target sum. Okay. Each path should be returned as a list of node values and not the node references. So this is a very important thing. So a root to leaf path is a path starting from the root and ending at any leaf node. A leaf is a node with no children. This is a very common terminology if you have already dealt with binary trees or binary search trees. So let's look at the example. So our given binary search tree is visualized. A binary tree is visualized, but generally it won't be visualized and it will be given as a list. So here we are given the root as 5 and the left node as 4, right node as 8. Similarly, the tree is built accordingly. So if you see, the root is given as 5 and the tree is given and the tree is already constructed. And the target sum is 22. So here we can see there are two options from the root to the leaf node. So there are 4 leaf nodes, so there must be 4 paths. So the path which has sum 22 is 5 plus 4 plus 11 plus 2, as 5 plus 4 is 9, 9 plus 11 is 20 and 20 plus 2 is 22. Similarly, another path where the target sum is 22 is 5, 8, 4 and 5, as 5 plus 8 is 13, 13 plus 4 is 17 and 17 plus 5 is 22. So these are the paths. And our output, we need to return a list of lists or an array of arrays, each of the array containing the path containing the nodes values in the path. So for the first path 5, 4, 11 and 2, we have to return it in the same order 5, 4, 11 and 2. And for the second one, we need to return it in the same order 5, 8, 4 and 5. Okay, let's look at the next example. 1, 2 and 3. This is the binary tree and our target sum is 5. As you can see, there is no target sum, so we have to return an empty array. The example 3. Here the root is given as 1 and there is only one node, left node, which is 2, and the target sum is 0. Again, we won't have any solution, so the output is null. So let's look at the constraints. Always remember to look at the constraints before you start coding. So the number of nodes in the tree is in the range 0 to 5000. Remember, when we scan the tree, we need to go through every node to find all the paths. Therefore, we need to do it within the range of 0 to 5000. And each of the node values can be in the range of minus 1000 to 1000. So we can directly use our integer to store these numbers, as the value can't be greater than 5000 into 1000 at the maximum. And the target sum will always be less between minus 1000 and 1000. So this is to indicate that we don't need to use large int and we can directly use integer. Okay. So the basic idea behind this problem is that we have to return a vector of vectors as the solution. And let's write a step function so that in each iteration of the step function, we just return one of these paths and add it to this array. So since we have to return an array of array, I just first declare a vector of vector int answer, and this will be the answer which I'll be returning. So return answer. So let me just write a step function. So let the return type of the function be void, as inside the function will add the path to this answer array. So let me rename it as void step path func. So inside the array we need what all we need. So we need this final answer array so that we can add it inside that, and we need to call it by reference. So vector of vector int and call it by reference, and then we need a element of the structure of the tree. So let me call it as root. So before that, let's look at the definition of the binary tree node. So we are given a structured tree node and it has values. What is the values? Int val, which is the value it holds, and tree node star left and the tree node star right, which are the left and right pointers. Then we have a constructor. When we do tree node of something and a value 0, it creates a value 0 and a left and a right pointer. Since this is not required in this question, but it just gives us an understanding of how it's done internally. We have another constructor with a value passed to it. Here if we call it like this, it'll create a tree node of value x and a left pointer and a right null pointer, since we haven't defined anything. But if we call the tree node function, constructor function, like tree node of int x, tree node star left and tree node star right, we get an output node with value x and a left pointer corresponding to this left and a right pointer corresponding to this right pointer. So now that we have understood how the tree works and how it's constructed, let's go try and solve this question. So as we have already seen, we have created an answer array and a root. This root will be the root at each step of the recursion. So once we go here 8 will be the root, and once we go here 4 will be the root. And we need also another variable called current sum, which needs to carry the sum up till that point of time. So when we are here, we can't go back. So we need the sum till say 4, like say 5 plus 8 plus 4. To know whether we are able to find the required target sum. And since we need to check for the target sum at the leaf node, we need the target sum. Okay, so those are the parameters we need, and while coding, if we need anything else, we will add it on the go. So let me call this same step function with the parameters we have defined. Answer, which is the one we need, and the root of the tree node from here, which will be the starting node. And for the first one, there's no path defined. Oh, sorry. And also we need another vector where we store the path. Say assume we are at 4 and we need the path till then. We need a vector, say 5 and 8 till that point of time. So let me define another vector of type int, because we are only storing the node values. It's asked and not the node references. So vector int, and let me name it as current path. Okay, so the current path at the starting node of the starting root of the tree is empty. So let me define an empty array, and I will pass a current sum as 0, and I will pass the same target sum from the above. So inside the recursion, first let's do some sanity checks. So if the root is null, you can write root equal to null or not root, just the short form. We just return. This is to prevent any overflowing in the recursion. Next, let's check for the base condition when we add the path to the answer array. This is when it's a leaf node. So what is the condition for a leaf node? The left arrow, root arrow left and the root arrow right should be null. So let me do that. So if not of root arrow left and not of root arrow right, means it is a leaf node. At this point of time, we need to check if the current sum plus the current, so the current sum holds the value of the sum till that node without that node. So the total sum will be the current sum plus the current node's value, which will be root arrow val. If this value is equal to the target sum, which means that we have found a path with the target sum. So in that case, you push back the, so you need to push back the current path to the answer array. But before that, so you will be pushing back the current path to the answer array finally. But before that, to the current path, we need to add the current node's value. So I will do current path dot push underscore back of root arrow val. Since here we are only storing the values in the array. So this is the case when there is a leaf node. Else we need to recurse both in the left and right path of the tree. So here to the current path I would be pushing the value of the root, since we have already traversed that element. And now I will be calling the same step functions left subtree. So step path function of answer, which is the final answer array, so there's no change in that. And here instead of root we need to call it as root arrow left, because we are traversing the left subtree. And current path, since we have already pushed back the root element, we can just send it as current path. And for the current sum element we need to pass the value of the root, because we have already traversed this element. Say when we are calling the left subtree and right subtree at 8, we need to call the value added with 8 up till that point of time. So 5 plus 8, then only we need to call the 13th one. And finally the last argument in our function is the target sum, which is not going to change. So that will be the target sum. Similarly, let me traverse the right subtree. So here also we call it with the same answer, but the node now we will have our root is the root arrow right, and the current path, since we have already added the root arrow val, we will have it as the same. And similarly here also we need to add the root arrow value to the current sum and then the target sum. I think this must work, but let's give it a run. So let me just check it once. Seems good to me. So answer of answer, and here we are passing an empty array. Okay, just let me just run the code. Yeah, as you can see, let's take this example and go through our code once more if you have any doubt, since I might have gone a little too fast. So initially we have this tree and we have only given the root node, which is the reference to the root node, and we are calling a step path function to find all the paths which add up to the given sum, say 22. So on the first call we will pass the step function as answer, which will be an empty array, followed by root, which will be 5, and an empty array for each of the paths. So till now we haven't found any path, and 0, which is the sum till excluding that root, and the target sum, which is 22. And then in the step function, since root is not null, it won't return, and again 5 is not the leaf node, so this function won't be executed. So to our current path we will add 5, and then we will recurse the left subtree, which is answer, and then root arrow left, which will be 4, the pointer to node 4, then the current path, which will have 5 in it already because we pushed it back here, and then the current sum, which will be 5 before that node because we are adding current sum plus root arrow val, and the target sum. Similarly for the right subtree. So when we come up till this point of time, when we come to the root node 11, say 5, 4, 11, the current path will already have 5, 4 and 11, and the current sum will already have 9 plus 11, 20. So when we come to the last leaf node 2, the current sum will have 20, and there will be no root arrow left and root arrow right, so it will go inside this solution. So now the current sum is 20 and root arrow val will be 2. So current sum plus root arrow val is target sum. So to our current path, which will already have 5, 4, 11, we will push back this 2, and then we will have the path as 5, 4, 11 and 2, and we will push this whole array into our answer array, which will have the current path. Since we are doing this for all the subtrees, because we are traversing left and right from every point, so this should recursively find all the required solutions. So let me just look if they have asked an order to return the solution. No, they have not. So I guess any order of returning this answer should work. So as you can see, that has been accepted, and it's faster than 72% of the solutions.